What if I told you that the electricity powering your phone right now started its journey at an unbelievable 765,000 volts? Yes, 765,000 volts. That's not just high voltage, that's an incredibly powerful form of energy, traveling hundreds of kilometers, just to light up your room. Right now, as you sit comfortably in your home, electricity is silently working behind the scenes, powering your lights, charging your phone, running your fan. But have you ever stopped and wondered, how does this extremely dangerous, high voltage electricity become safe enough to use in your home? Today, we're going to uncover the complete journey of electricity, from massive power plants to the tiny switch on your wall. Power generation, everything begins at a power plant. Power plants come in many forms. Some burn coal, gas, or oil. These are thermal power plants. Others use the force of flowing water, hydroelectric dams. Some use nuclear reactions, while others rely on renewable sources like solar panels and wind turbines. But no matter the type, they all have one thing in common. They use energy to spin massive turbines. These turbines rotate at extremely high speeds, and they are connected to a generator. Inside the generator, a fascinating process called electromagnetic induction takes place. As the turbine spins, it creates electricity. But here's something surprising. The electricity produced at this stage is only around 11,000 to 25,000 volts. That may sound like a lot, but for long-distance travel, it's not enough. Why? Because when electricity travels long distances at low voltage, a large portion of energy is lost as heat. This loss is inefficient, expensive, and wasteful. So what's the solution? Increase the voltage. Transformer. Before electricity leaves the power plant, it passes through a powerful device called a step-up transformer. This machine increases the voltage dramatically, from about 11 kilovolts to as high as 765 kilovolts. But why is increasing voltage so important? Here's the science behind it. When voltage increases, current decreases, and when current decreases, energy loss in the form of heat is reduced significantly. This makes electricity transmission more efficient, more reliable, more cost-effective. That's why countries around the world use ultra-high voltage lines like 400 kilovolts, 500 kilovolts, and even 765 kilovolts. Transmission lines. Now begins the real journey. Electricity travels through massive transmission lines, supported by tall steel towers, stretching across vast landscapes. You've probably seen these towers, along highways, across fields, even over rivers. These lines carry extremely high voltage electricity across cities, mountains, and long distances. But have you noticed something unusual? The wires are completely bare, no insulation. Why? Because insulating wires at such high voltage would be extremely expensive and technically very difficult. Instead, they are placed very high in the air, keeping them safely out of reach. These systems also use something called three-phase power. This allows electricity to flow more smoothly and deliver consistent power, high voltage danger at 765,000 volts. Electricity is extremely dangerous. It doesn't even require direct contact. It can jump through the air, creating an electric arc. This can cause severe damage instantly. That's why transmission systems are carefully designed, monitored 24/7, and protected with advanced safety systems. Substations. As electricity approaches cities, it cannot be used at such high voltage, so it enters a substation. Here, the voltage is reduced step by step from 765 kilovolts to 400 kilovolts, to 220 kilovolts, to 132 kilovolts, and then to 33 kilovolts. Each stage makes electricity safer and more usable. Substations also play a critical role in controlling power flow, protecting the system, and managing distribution. Distribution network. Now electricity enters the distribution system. From substations, it flows through smaller lines into local areas and neighborhoods. Voltage is reduced even further, from 33 kilovolts to 11 kilovolts, then from 11 kilovolts to 400 volts. You've probably seen small gray boxes on electric poles. These are distribution transformers. They bring voltage down to a level suitable for homes. Your home, now electricity finally reaches your home from the transformer. You receive around 400 volts in three-phase supply, which is then split into 230 volts for everyday use. This powers everything around you: lights, fans, televisions, chargers, and more. Before entering your home, electricity passes through safety systems like energy meters, circuit breakers. So if anything goes wrong, the system automatically cuts off power. Safety systems. Electricity networks are protected by multiple safety layers. These include circuit breakers, relays, surge protectors, grounding systems. They constantly monitor for problems like overload, short circuits, faults, and instantly shut down power to prevent damage. Amazing facts. Here are some incredible facts. Electricity travels almost at the speed of light. A single transmission line can power millions of homes. Transformers can last over 40 years. Voltage is increased and decreased multiple times during its journey. Time you flip a switch, remember this incredible journey, from a massive power plant to ultra-high voltage transmission lines, through substations, into your home. All of this happens in just seconds. Electricity isn't just power, it's one of the greatest engineering systems ever created. If you enjoyed this video, like, comment, subscribe. And remember, the power in your home has traveled an incredible journey.